Hello, my name is Rez, and I am a professional game programmer, and I do electrical engineering as a hobby. So let's talk about the motor itself. What's in this? What's here? So it does a good job of showing you this, like the gearbox, but what is this guy, this right here? Well, in order to understand this, we have to understand something about electricity, and one of the major properties of electricity. There's something called electromagnetism, and it basically works like this. So if I have like a little battery here and I connect a little circuit to it, maybe it's a simple little light like that. This would just be a little LED circuit. Here's an example of what that would look like right here. And so if I were to connect this up just like this, we'll hook this guy up. And I'm not going to be able to do this with 1.5 volts. So let's crank this up to like 6 volts or so. Turn this on, and there we go. So there's electricity flowing through here, as we can see, because the light is turned on. Anytime electricity is flowing through a wire, you get a corresponding magnetic field. You create there's essentially a magnet or a magnet-like phenomenon that is surrounding this wire, just as electricity is flowing through it. It makes sense if you think about it. The flow of electricity is, if you have a bunch of atoms here and electrons, it's these electrons essentially bouncing from one atom to another. So it makes sense that some stuff's going to go on there in terms of magnetism. So the this is something that is used everywhere in electronics, right? I mean, it's a fundamental principle of electricity, and we use it constantly. Um, Anytime you plug something into the wall, if it's any reasonably complex thing, it probably goes through a device called a transformer. This transformer is something that's going to step your, 120 volts or 240 if you're in the UK or elsewhere, depending on where you're from, but 120 here in the States, and it's going to step that down to something less deadly, basically, or less, something that's going to be able to utilize. Um, Electricians use it all the time. So this is a multimeter. This is something that lets us detect electricity. And there's this little NCV button. I don't know if you can hear it, but you can see the light. So if I just hold it down, it just chirps and does nothing. That's it. It even says no contact voltage detector, which, by the way, NCV is no contact voltage. So, however, if I were to take this, let me zoom this down and pull this over here. Like if I were to just come over here, there is a plug that is connected here. If I were to just press this, nothing's going to happen. But if I get closer to this, it's going to detect the magnetism from there, and there it is. I don't know how well you can see that. I think you can see that okay. Pull it away, right? That's detecting the magnetism that's coming from that. It's the no contact voltage detector. Um, Now back to our motor. It's using the same principle as this no contact voltage detector. It's the same idea, kind of. We're just using it in a different way. Um, Very basically, and this is just how one thing, I'm pretty sure this is a brushed motor, so this is just how one thing works. Inside of this, we have, kind of two wires that come out like this. And so we may, we'll have a positive and a negative, and these connect to a coil. Now, the thing about a coil, literally, and when I say coil, I mean literally a coil of wire. Uh, I mean, you could literally do this, and now this wouldn't work super well, but you can create a coil of wire. It's called an inductor, and it can concentrate that electrical field. So we have this coil here, like this, and this coil will create this sort of electrical thing. So it's going to come out here and to this like brush. I'm trying to draw this. I'm not an artist, but I'm trying to draw this in a sort of 3D fashion. It sticks sort of out like that. So it creates this like, so there's this brush, and as current is flowing, we have this magnetic field. Now, connected directly to these things, I'm going to butcher this, but I'm going to try. We'll see how well this does, because again, not an artist. But we have these blocks. Here's another one on this side. Um, yeah, this one looks like it's further than it should be, but there we are. And one of these is a North Pole. One of these is a South Pole. These are real magnets. So these are permanent magnets. So they're actual magnets. Um, what we do here is as current flows through here in this, like, there's this ferrous brush, it's going to create a magnetic field. Now, as soon as we have a magnetic field around this thing, these magnets are going to react as magnets react. They're going to attract and repel just like normal. Thus, we're going to get this spinning motion. You can actually do this yourself if you have, and I don't have permanent magnets here, amusingly, but you could do it yourself if you set up a two magnets, you could, and had like a little spinny thing, you could get it to actually spin. You could get something to spin and move just in a very similar fashion. That's all that's happening. Now, if you reverse current, so if I were to flip these and I would say, okay, now this is positive and this is negative, it would actually reverse the magnetic field, which is why the motor will go in the other direction. So that's the basic idea of how this works. That's what's going on under the covers. And this is a brushed motor. There are many, many different kinds of motors. Here are several. I think some of these are actually, most of these might actually be brushed motors, but this is a heavy duty 12-volt motor that came from a dead Roomba. Here's another one. I don't know where this came from. This is a stepper motor, so this one's slightly different. Here are some more motors from fish. Oh, from a like a big mouth Billy Bass. That's what those guys are. Here's, some others that I have a bunch of motors of varying shapes and sizes. I've got these little tiny ones here as well. So I've got these little motors, because when you have electronics as a hobby, you collect weird stuff like this. There's also servos, which are these guys. Servos are it's the same idea as a motor. These are very popular. You'll see these in hobby stores, hobby sites and stuff for electronics all the time. These are incredibly popular. These are very, very cheap, very simple stepper motors or servos, very simple servos. And here's some more complicated servos. These are some more heavy duty ones. Servos are very similar to motors. They just tend to be more exact and often have more torque. They're better for robot like manipulation. Like if I were to have an arm that was going to come and like grab a thing, right? These would be servos because I could more easily control them. Motors are cheaper and they're perfectly good for just like, okay, I want to spin this thing, off we go. And that's what they're used for the most part. So that's it. That's the technical side on what a motor is and basically how it works. So thanks for watching. I will see you all tomorrow.